This short video aims to give a first basic introduction to process physics. This is a way of doing physics developed by Australian professor Reg Cahill that does not model the natural universe with laws of nature, but rather with routine of nature. Getting a firm grip on the routine of nature idea is probably best done by first looking at another issue in physics. Namely, according to Aaron Schrödinger, physics as we know it suffers from an inconvenient weak spot. He says that the scientist subconsciously simplifies his problem of understanding nature by disregarding or cutting out the subject of cognizance. Inadvertently, the thinker steps back into the role of an external observer. So, although physics aims to give us a factual map of the world, it cannot help but leaving out a crucial element of nature, ourselves and our subjectivity. This is where another well-known figure in physics is to blame, Galileo, known for his many gravitational experiments. He was in fact the first one in physics who made the actual distinction between target and subject side. This enabled him to focus only on how the target side of nature worked, while ignoring the question of what the subjective aspects were all about, and how these aspects colored our observation. So despite its tremendous success, this method also had some downsides. The exclusion of subjectivity, but also the confusion if the target-subject split should be drawn between the ball and the instrument, between instrument and observer, between the eyes and the brain, or even between the brain and its mental images. Most physicists, however, have simply ignored these problems and still trust on the external observer method, similar to Galileo looking at his brass ball, while leaving observer and environment out of scope. In an attempt to compensate for the incomplete picture this gives us, we might enlarge our target system as much as possible until the entire Earth is being covered, for instance, so that all observers are automatically included. But such an attempt can only introduce a dummy version of the observer, like this, and would therefore still leave out the observer's subjectivity itself. On top of that, whenever it is attempted to apply physics to nature as a whole, this would require us to place the observer outside of the universe, and as physicist Lee Smolin pointed out, this is entirely impossible. So if we want an inclusive instead of an exclusive portrayal of nature, we should arguably opt for another way of doing physics. Instead of taking the external perspective on things when doing physics in a box, as Lee Smolin calls it, we should realize that we, conscious observers, are actually inside the same natural world that we are trying to make sense of. Accordingly, we are not just the end station of incoming sense data originating from some external source of information. We are instead seamlessly embedded within nature organisms that get to make sense of the greater embedding whole of nature by actively living through their action-perception cycles, thereby gradually sculpting an increasingly more solid sense of self and world. All in all, nature should be seen as a giant, undivided totality. No separated target and subject side, and no split between source of information and its destination, but a process in which all internal goings-on inform or make a difference to all else. Like this, we can see nature and all its contents, including ourselves, as being in a constant flux of mutually informative affairs. Now imagine that we could erase all our familiar revolved structure from nature so that only low-level flux would remain. In that case, we would basically end up with a vacuum-like background noise like this. In process physics, such a noisy background process is used to model emergent structure formation in the early universe. The process physics model, which has its roots in quantum field theory, starts out with a relational matrix grid, whose individual cells are linked together through an iterative update routine. This update routine contains a noise term that, together with a system-wide cross-linkage term and a precedence term, gives rise to a self-organizing update process with emergent connectivity patterns. Like this, starting from initial absence of connectivity, we basically get a giant system of constantly fluctuating fore and background patterns. So in contrast with mainstream physics, where typically only the frontline items of interest receive attention, here both fore and background patterns are of the essence. And once the foreground patterns start to emerge from their low-level background, they will start to exhibit all kinds of novel features that we also find in nature itself. For instance, inertial, gravitational, and relativistic effects, non-locality, but also emergent three-dimensionality. Analogous to convection cells or the cells in Gray-Scott reaction diffusion systems, the emergent patterns organize themselves from an initially uniform background into three-dimensionally distributed connectivity nodes. These primitive cell-like connectivity networks can then branch out to higher and higher levels of complexity, thus giving rise to the formation of the early universe. This is what the evolution of the universe looks like when viewed on a supergalactic level of organization. As is shown here, it will spontaneously take on a neural network-like structure. And whereas our current mainstream theories need to invoke exotic concepts like dark matter and dark energy to conform with this kind of structure formation, process physics spontaneously gives rise to neural network-like patterning from the get-go. Moreover, Erik Verlinde's alternative theory of gravitation seems to point much more towards the process physics interpretation of nature than that of our current standard cosmology. All in all, we can conclude that our familiar mainstream physics can be thought of as doing physics in a box, whereas process physics can be characterized as a way of doing physics without a box. Next to that, the mainstream physics account of laws of nature and initial conditions is contrasted with the process physics narrative of routine of nature and initial randomness. Furthermore, while mainstream physics relies on empirical data to get an external picture of nature, process physics is based on the mutual informativeness within its connectivity network to get a self-organized modeling of nature. And although process physics can indeed be seen as an alternative for a conventional physics in a box, it can also serve as a complementary way of doing physics. Like so, we can get a binocular physics, in which physics within and without a box can be each other's standard of comparison. The link with Erik Verlinde's alternative theory of gravitation, for instance, can be seen as a promising illustration of this. Thank you very much for your attention. I hope you enjoyed this video. Thank you very much. Bye-bye.